Hello out there in geometry world. This is geometry section 7.3, a little more with similar triangles. So today we're going to talk about some other ways to determine whether two triangles are similar. In our past section, we were using the definition which said that all angles must be congruent and all corresponding sides are proportional. Now, we have a couple shortcuts here, and this is much nicer than have to prove all of them. So our first shortcut, instead of having to prove all angles are congruent, we can prove two similar triangles by just proving two angles congruent. So let's fill this in here. If two angles of one triangle are congruent, remember in similar triangles we're talking about congruent angles, then the two triangles are similar. All right, so what does this look like? Let's draw a little triangle. A, B, C. There we go. Now let's say angle A and a big triangle D, E, F, congruent to angle D. And then we also know that, let's say, angle B is congruent to angle E. Okay, there we go. That's enough for us to say that triangle ABC is not congruent. Let's make sure we fix that symbol. I want to make sure it says similar. Just our squiggle. Similar to triangle DEF. And everything else that goes along with it. Meaning angle C congruent to angle F and all of our sides proportional. Okay, so all corresponding, I'm going to abbreviate that, sides proportional. Just like we've been doing, we can set up those ratios and proportions to find missing sides. All right, the next one is side similarity. Now, this is not like side congruency, because the sides don't have to be congruent. Okay, if the corresponding side lengths of two triangles are not congruent here, proportional, which again means we have that common scale factor or common ratio between them, then the triangles are similar. Remember, we're not looking for congruent triangles, we're looking for sides similar, which means same shape, different size. All right, so here's what we know. Let's say we have triangle ABC again, this little guy, and let's say we know this side is 1, this side is 2, and this side is, actually let's say, because that's not going to make a triangle, let's say that this side is 1, this side is 4, and this side is 3. All right. If we take that and now look at DEF, if they have the same scale factor, let's say we multiply each of these times 2, then this would be 1 times 2, back side could be 2, 4 times 2, 3 times 2, and there we go. So there's another triangle. So that's that idea. We can then conclude that these triangles are similar, and everything we know about similar triangles is true. Okay? The next way we have is side angle side similarity. So now we're kind of combining these ideas. The lengths of two sides of one triangle are proportional. So again, not congruent, but proportional, and that's two pairs of sides. So the lengths of two corresponding sides of another triangle, and the angles are congruent. The angles are congruent, then the triangles are similar. So we're kind of combining these two ideas. All right, so we might have something like this. So let's say again we have this little triangle ABC. Let's say we have sides are 3 and 4, and then we have triangle DEF. And we know that angle B, this is our included angle. Notice it's in between these two sides. And let's say again we have a scale factor of 2, which means 3 times 2 is 6, and 4 times 2 is 8. So now we see those two pairs of proportional sides and that one congruent included angle, which gives us that conclusion again that triangle ABC is similar to triangle DEF and everything that goes with it. All right, so that's what we're going to be looking for now in these different examples. So here's section 1. Use the diagram to complete the statements. Triangle ABC is similar to, let's see, let's match them up. A, B, C. Look, A has that 2. That goes with D. See how it's got the 2 marks there? So we got to put that first. Triangle D. B doesn't have any mark in it. Neither does E. F has that 1 arc, and that corresponds with C. So there we go. Because of, now look at what we have. 2 congruent angles. So we just say because of angle, angle. Alright, so now let's fill in the blanks for our ratios here. Now we're going to match up our corresponding sides. AB goes with DE. Look at our order. AB, DE. There we go. And then EF is the bottom of this triangle right here. That goes with BC. We can use our similarity statement to match those up as well. And then CA goes with DF. Notice for our proportion, guys, all the sides here on the top are from triangle ABC. All the sides on the bottom are from triangle DEF. All right, now we can match up all these different ratios. AB we don't know is X, we put there. Okay, BC we know is 8. BC corresponds with EF, that's our Y. And then CA we know is 6, and DF we know is 16. All right, so that gives us our extended proportion. Then we can go ahead and solve these. So split them up to solve for whatever you want, okay? Now, angle B, we have congruent to angle E. We already talked about that. That should have been the easy one for you to see. Our scale factor here is given by this ratio right here, 6 over 16. Okay, let's simplify that. Divide by 2, divide by 2. So that gives me 3/8. Now, it looks like we don't know which way we're going, so it could be 3/8 or it could be 8/3. It's reciprocal depending on if we're starting with the smaller one or the bigger one. All right, now you have your proportions there. Go ahead and solve for X and Y, and I got 4.5 and 21.3 repeating. All right, don't forget that repeating sign. All right, now in 7 and 8 in section 2 here, we're going to determine if they're similar or not. So right now we're looking, can we use angle, angle? Can we use side, side, side? Or can we use side, angle, side? So right here I see I have a 47-degree angle. I have a 90-degree angle. So 90-degree angle, 90-degree angle. There's one angle congruent. But this is 47, this is 43. So I got to calculate this missing angle here. 180 minus 90 minus 47, and that gives me 43. And then I'm checking then. If that one's 43, and it is, then we're good because we know this one has to be 47. So we know that these are similar by angle, angle similarity. All right, now our next ones, I have 85. There's one angle congruent. Nice. All right, now this one's 50. That means that's going to give me, let's see, 180 minus 85 minus 50 gives me 45. 180 minus 40 minus 85 gives me 50. So notice I have one angle congruent, but I don't have a second one, so these are not similar here. All right. Take a second, pause it if you need more time with that. I'm going to flip it over to the back. All right, 9 and 10, we're doing the same idea, but now we're looking for different combinations of similarity. So check this out. I have a side, a side, a side. Those angles are congruent. Hopefully remembering those names, those are called vertical angles. All right, vertical angles. So congruent, congruent, there's our vertical angles. Okay? Why do they keep disappearing? All right. All right, now they're staying there. Okay, so now we have the angles. We only have one pair of angles, so now we got to look at the sides and determine, are these sides proportional? So we're matching up these sides. Now remember, our trick from last section is we're looking at which sides are bigger. So take the bigger sides in each triangle. This side 8 is bigger than 7. So that I'm going to match up with this side 24. So when I look at it, I'm making a ratio. We're checking to see if the ratios are the same. If I simplify that, 8 divided by 24, I can divide each one by 8. I get 1/3. Now look at my other sides. I got 7 and I got 20. I can't even simplify 7 over 20. So then we can check the decimals and see that they are going to end up being different. So we know that these are not going to be similar because we don't have the proportional sides that we need. All right, we're going to do the same thing with this one. Now notice, again, angle, angle. Good. Now that's the included angle. Look at the sides. That's congruent. Those are congruent. This one should be really obvious, okay? So our ratio then is 72 over 132, and of course that's going to be the same because all the sides are the same. So these are similar, and this is an example of our side angle side similarity. All right, 11 and 12. Now look, we don't have any angles. We have a whole bunch of sides. So now we're checking, are all three pairs of sides proportional? So if we don't have angles, we got to check all three pairs. So let's use that trick again, and let's start with either the largest ones or the smallest ones. Okay, so I'm going to start here. The largest one here is 70. The largest one here is 154. So when I write my similarity statements, or sorry, my ratios, 70 over 154. All right, go to the next biggest. The next biggest is then going to be 110. The next biggest here is going to be 50. So again, I start with this one, 50 over 110. Then the last one I have is going to be 35 over 77. And again, we're checking to see if these all have the same ratio. Now, if you put this on your calculator, because these ones aren't as easy to simplify, I get 0.45 repeating, 0.45 repeating, 0.45 repeating. So these are similar, and that's the example of our side similarity. All right. And number 12. So let's go ahead and fill in what we know here. Or sorry, yeah, 12. Let's go ahead and fill in what we know. So look at this. I got pieces. I got 27. I got 64. 64 is the side here, AC. Okay, now here I got 33 and 43. Look at this big triangle then. 33 plus 43 gives me 76. That's what we're going to be comparing. Again, let's use that trick that we just used, and let's start with our largest sides. So I have 64, 99, and 76. 99 is definitely my largest side. 27, 42, 33, my largest side. So we're checking our ratio 99 over 42. Okay, go to our next largest. I have 64, I have 76. We're going to use that 76. 76 over, then we have 33, next largest. And finally, our smallest side are going to be 64 over 27. Okay, and then when we go ahead and calculate each of those ratios, plug into our calculator, and let's see what we get. All right, and I ended up getting them to be differently, which means they are not similar. All right, and then we have a couple applications down here, which really is getting into what we really want to make sure we're good with in this chapter. All right, find the length of CD given that triangle EAB congruent or similar to CAD. All right, let's label what we know. We have AD, that's a side in the small triangle. DB is 5, that's a piece, not a whole side. So let's go ahead and do this right away. That big triangle here, that whole side is 8. Okay, make sure you're using whole side lengths. EB is 16. All right, we want the length of CD. Let's call that X. Now this should be pretty obvious for us. Match up our corresponding parts. Okay, let's look at our small triangle. We have side AD, 3, corresponds to side AB in our large triangle. There's our ratio that we need, our scale factor. Then we go to our small triangle. We want CD, which is X, and that corresponds to side EB, which is 16. All we have to do now, cross multiply and solve, and we're going to get X equals 6. All right. Number 14, find the length of NQ. Okay, so now we want NQ. Let's put our X there so we keep track of what we want. Given that triangle NQP is similar to TQR. Now, check it out, guys. NQP, that goes with TQR. So that means these two angles are congruent. Okay, so keep track of that when we do our corresponding sides. This is where people tend to make mistakes because they're not lined up. So N goes with T, P goes with R. All right, QT, there we go, is 4, PQ is 3, and RQ is 6. Okay, now don't reverse these. Check it out, make sure we're good. Look at our corresponding parts. We have NQ. That goes with TQ, just right here. All right. We have now RQ. Look at our similarity statements. And RQ goes with, here's RQ, QR goes with QP. So we can see those. So let's set up our proportion. X over 4. I highlighted those so we make sure we keep them straight. Now I started with this top triangle, so that means 3 goes on the top here, equals 3 over 6. Okay, cross multiply and solve. X times 6 is 6x, equals 3 times 4 is 12. Divide by 6, divide by 6, and we get x equals 2. There we go. All right. Next one is our famous flagpole problem. Get used to these. You're going to see them. They come up on quizzes. They come up on tests. They come up in notes. They come up on the ACT. All right, so make sure this makes sense. Now, here we have two overlapping triangles. The man makes one triangle, the height of one triangle. The flagpole makes the other triangle. Their shadows are overlapping. So look at what we know again. Everything in this diagram is labeled. Okay, that guy's 5 feet tall, shadow 6 feet. The shadow of the flagpole now is this whole thing, not just the 12, the 6 and the 12. Make sure you label that. That's really important. So now, when we write a proportion here, let's start with the heights. The guy is 5 feet tall, the flagpole is h feet tall. We don't know it. The guy's shadow is 6 feet, the flagpole shadow is 18 feet. Okay, there's our proportion. All right, really easy to set up. Make sure that you keep those straight. Make sure that you keep the corresponding parts lined up in our same ratios. Now all we have to do is cross multiply and solve. So 5 times 18 is going to give us 90 equals 6 times h. And all we have to do is divide by 6 to solve. And that gives us our flagpole's height is 15 feet. All right, ladies and gentlemen, that's it for section 7.3. If you have further questions, just make sure you check the worked out solutions and ask your teacher. Nice work.